The second presentation is by Liang how to pronounce Liang Wang, and he's a master course student of NTU and co-organizer of Taiwan R user group. Today his presentation is handy parallel distributed computing in Python. So please.
Hi everyone. Today I'm going to talk about handy parallel or distributed computing in Python. And my name is Liang Wang, and you can call me Liang. Okay. And you can find my slide here through the PyCon website. Click the code note and find the correct page. My talk number is number 36, and you can find my slides here because, well, I think I cannot make all my slides in 25 minutes. And I'm a master student at National Taiwan University, Center of Genomic Medicine, and well, I'm trying to learn how to speak DNA here, and my major language, programming language, use R and Python, and I'm the Taiwan R co-organizer, and I'm also the staff of PyCon APAC this year, and I'm responsible of all the web content on here, both English, Chinese, and Japanese. So I would like to hear your feedback. So if we have too many grammar errors or something like that, and please tell me. Okay. Today I'm going to talk mainly these three modules: multiprocessing, and IPython Parallel, and Celery. Well, when we are doing data analysis, and most algorithms cannot support multi-core, or your boss can allocate a huge server for you, but actually you can use most of them, and is really sad before deadline, and your and engineer's time is more valuable than the computing time. So you might not want to try to parallelize all your algorithm you use. So but when we are doing data analysis, the situation we face is we are processing a bunch of data together, and most of them can be separate. So you can distribute your data. Probably that if you have 10 rows of your data, then you can separate all 10 rows to separate machine or separate process. So you can make it parallel or distributed. Okay. And so that's exactly what I want. So today I'm going to give you some basic tool to let you do that, and well, it may introduce too much overhead or something, but it's really a handy way to do so. Okay. And well, I didn't come up with some very interesting example, but I try to validate prime numbers, and those prime numbers are like that, and it's a pretty big number, so probably you can do it in very fast. So here is a simple way to verify it. Just divide it by a series of integers to see if it's a prime. So you can divide it. So the simplest way to do so is verified by a for loop. So you verify each prime one by one and return their answer into a list. Okay. And here we want to benchmark each method we use. So I use the timeit module in Python, and you can easily to benchmark how long your Python function runs. And if you validate your primes linearly, so you probably get probably 5 of probably 10 minutes to verify all the primes in that list. So we probably want to do parallel and maybe distribute it. And first, we'll use the Python standard library, so there's no dependency for third-party package. And before talking about multiprocess or multi-thread, first, I guess many people might know, but Python still have multi-thread and multiprocess module in Python standard library, but because of Python's geos, and the thread will not run as you expected. Okay, so if you really want to make them computing at the same time, you should use multiprocess. And this picture is from David, and he has a great talk about understanding geo. Okay. And using the Python standard library multiprocessing, having a multiprocess is quite easily. First, you define the pool and specify how many processes can run at the same time, and then you map your function and your value input through the pool's map function, and you can spread your primes. Okay. And well, if you run this through the interactive mode, and it can produce the values, but if you try to end this Python interactive shell, then you'll give you an endless traceback, and so that's you should never run this interactively. Okay, and there's another module called concurrent.future, which is available in Python 3, and well, it's not safe to use it in interactive mode, but well, I'm going to introduce this so I can talk about some async APIs. And first, you can use it through the process pool executor, and you can specify how many processes you want to execute at the same time, and then their API is quite similar. You map your function and your input values, and then you can run it parallelly. Okay. Well, so I mentioned some async API, but if you use through the context manager through the with block, then actually your code will block at the this line when you exit when you leave in the with block. Okay. If you want to run it asyncly, run it in async mode, then you need to create the process pool executed by yourself. So that's how you do it. And okay, well, reading code is not easy for afternoon, so let's just watch the result. And I try to do another thing that just print a message, so you can know that when your Python code is trying to validate your primes, you can still do something else. Okay, so that's basic async stuff. Okay, and if you want to do your job, if your job is I/O heavy, then probably this way is not the best way you want to do. So you can try async I/O and use the design pattern called coroutine, and generate use a pattern called coroutine, so you can use the async mode instead of having too many callback functions. Okay, and yeah, it's quite like magic if you listen to the talk given by TP. And yeah, here's his slide, and he's talking about a tulip, which is later become the standard module called async I/O in Python 3.4. Okay, and using the concurrent future can also it also support multi-thread mode, so you can use a thread port executor and to run your functions. But since this validate prime is not an I/O bound job, is it will your CPU will raise 100%. So because of the geo, you can gain computation boost by having multi-thread mode. Okay, and I put my demo code here so you can try it at home. And here is some benchmark that if you run it through the first for loop style, then you can it takes about 42 seconds, and well, if you run it in multiprocess mode, then you can get roughly 8 seconds, but you will not give a full speed up. Here I use a 12 core machine, but you will not get a 12 you will not speed up by a factor of 12 because there's a forking process overhead, and here the each function runs just some seconds, so the overhead is quite significant here. So you can see it just boosts 5 times. Okay. And I'd like to give a short summary about using the built-in modules. That is quite easy to write, and there's no dependency. But if you want to, sometimes want to just try an error way to find how to work on our data, then you will fail in the interactive mode. Okay. So it's bad when we want to do some data manually, and also it cannot be scaled across machines. So yeah, and it's hard to find a 100 core server, so you get a limited scalability. Okay. So I would like to introduce IPython Parallel, and IPython Parallel has a lot of good stuff. And first, you get all the function you want in IPython, and so it can be both interactive and parallel. So it's very useful in data analysis, and the IPython Parallel can scale across multiple machines, and it supports a common scheme like MPI, PBS, or SGE. Okay. Simply awesome. Okay. And install an IPython notebook, IPython Parallel is quite easy. You just need to using the pip. And for Windows, well, you can find their package binary on this site. Well, and if you can handle that, well, you should use Linux first. And here's how IPython Parallel work, and this diagram is copied from IPython official site, and I add some note on it, and it mainly had 4 parts. First is the I'll use point, and first is the client part, which is probably your notebook or where you run the IPython shell. Okay. And what IPython do is the down 3 main parts. And first, you have IPython engine, and it's just an IPython shell, and you have each engine corresponds to a process on your machine, and you have the similar behavior as usual Python user Python shell. So if you enter a command and let it execute, and it will be blocked. Well, maybe I've not mentioned, but IPython Parallel can execute it in async mode. So how IPython achieve how it makes you feel like it's running async is it had a scheduler that one scheduler communicate with one engine separately, and it has a queue to store your user's input. And yeah, so when you are executing your command, you can feel like you are running a sync mode, but actually in IPython engine it is blocked. Okay. And here is a hub that monitor all the status of schedulers and engines here. So if some engine is dead or not respond, so the hub knows it. and all these and hub and scheduler forms IPython controllers. Okay. And the terms here is quite important because on the IPython documentations you will see IPy controller and IPy engine. So, and your command will be IPython controller and IPython engine. So these, well, you might need to look at this diagram several times when you want to set up your IPython parallel system. Yeah. And for client side, you will need to connect the controller first, and lead through the IPython profile. And the default profile is it will start. You will connect to your local your default IPython controllers, and which your default IPython controller will start IPython engines on your on the same machines with how much the core you have. Okay. And you communicate with communicate with those IPython engines through a view. Okay. And when you connect, and the view can access to separate engines, but it's just like a list that holds each engine's instance. So you can, if you specify the whole engines you want, so here's a direct view. Probably I will explain it later. Okay. And to start, the IPython cluster is quite simple. If you just want to have a demo or just want to a quick start, and you can use the command line IPy clusters start, or you can start it through your IPython notebook. Okay. And it supports many ways to start the IPython cluster. You can you can make it through SSH, or they had many setups, and you should check out the official documentations. Okay. And this is how we run our prime validation on IPython Parallel. First, you get a direct view, and this demo is run on my 4-core machine. So when you get all the engines, and you will get 4 engines, and it had an ID on it. Okay. And here we use all the engines, so we just specify just all the engines here, and we will return a direct view. And if you see our since it's just a regular Python shell, and if you want to use some library that is not import defaultly, so you need to import it before you run your functions. So here I need to import math here, and then I can pass my functions here with my values here, and the IPython Parallel will handle all the parallel stuff here. So in a sync mode, and you can get your result here. So you will collect your result, and if I give it 8 primes, and you will try to separate on 4 engines, so probably each engine get 2 input here. And when you get it, and you will maintain the order of your how you specify your primes. Okay. And if you combine it with IPython magic here, and you can use a block magic called px, so double percentage px, and then the following code will run on the remote IPython engines. Okay. Okay. Well, I will not explain the following comments here. It's quite simple. Okay. And you can find a more detailed on how to use IPython Parallel on this notebook. And I have some comments on it. Okay. Okay. And you can, this is hot by MB viewer, so you can download this IPython notebook and run it on your local machine. And well, it's really easy to use on IPython Parallel, but and it provides some scalability. across a machine, and you can interactively run your code. And well, because it communicates through the network connection, so you'll get extra overhead for network messaging. And if you want to pass your value across IPython engine, your object will need to be able to be pickled. And well, but most times the IPython handle your object correctly. So in my demo here, I can pass a NumPy array, and I scattered it, and I collect it, and everything just works fine. Okay. Finally, I'll introduce Celery, but I guess just a quick introduction. And Celery is an async distributed task queue, and mostly you use it with an RabbitMQ, which is an message queue that it implements a message queue protocol. And what it do is that when you run the task, and it will put it into a message, and it specifies some argument about your task, and you will pass it through the message broker here, and message broker will know how to deal this message and pass it to some Celery worker, and after the worker finish the job, and will return the result. And you can specify either to put the result into the database directly, or just return back to the function code. Probably the diagram here is more easy to understand. That here is your code that executes some task, and you will pass it to the RabbitMQ, which is a broker, and you can use other broker that such as Redis or other message queue, and the broker will know how to distribute this task, and it will distribute it on all the Celery workers, so you'll get a distributed computing. Okay, then the result can return to either a database or a cache. So when you ask for the result, and you will just find the result back here. Okay. And well, to use a Celery is quite easy if you just need a default setup. Here is how you define a task that can be run on Celery. And if you try to call this task, then you can Celery add a decorator on it, and so you can use, for example, I want to validate my prime, so my function become is prime.delay, so it will use the async mode. So here there's when you want to get a result, and you will try to fetch your result from the result cache here. Okay. And well, okay, here is some summary about using 3 different modes to run to do parallel or distributed computing. First is the built-in mode, and well, the second is the IPython Parallel, and last will be Celery. Well, here I summarize summarize their features. And for the triangle signs, does not mean that it cannot do, but it requires you to write some code, and well, maybe not easy as you expect. And for negative sign, is you need to write plenty of code. So it does not mean that you cannot do this, but it's a bit of hack here. And in fact, you can use all these 3 modules together, and so yeah, you can just design on your own. So okay, first I need to so let's look back on how we implement our parallel job. That is quite easy to use, and API is mostly clean, and you can boost your computation by some factors. And yeah, you can, if you use IPython Parallel, and you can come out your how to execute, how to analyze your data by try and error, and for those heavy jobs that probably runs a few days, well, can have a significant performance improvement. And well, the most important thing that your algorithm is matters. Your algorithm matters. That if you find a good way to validate your prime, and probably you can speed up your execution time by many factors. Yeah. And well, our naive way comes with price that you are actually copy your objects a lot, and the memory usage will be high, and you'll get some extra overhead. Well, if you try to avoid copying object, then you can use database. And well, if your memory is high, well, if using database is not a solution, then probably you need to increase your memory. And if the overhead is unacceptable, then you probably should avoid this pattern. Okay. And yeah. So if you you need to just put these tools under your pillow, that and you definitely need to look at it. And well, the real parallelism is quite hard, because here we don't talk about how to communicate with each parallel process, and but there are some quite simple situations. And hope you enjoy PyCon APAC, and yeah, that's my talk. Thank you.
Thank you very much.